Okay, hello. I'm going to do day 14 of Advent of Code. Um, you might be asking yourself what happened with day 12 and 13. I was away during the weekend, so I did get them done, but I didn't make videos for them. So if you want the code for that, check out the code. It's in the course. I will say this, that the latter part of day 13 is pretty tricky, and um, so um, I actually um, I don't know if I cheated. I guess I cheated. Um, I was just browsing Twitter and I saw someone make reference to their solution to it before I did it, and so I didn't look at their solution was in Mathematica, but I looked at what they made reference to. They made reference to this thing called the Chinese remainder theorem, which apparently, if you're familiar with cryptography, is a big thing. I had actually never heard of it. And so, if you have that Chinese remainder theorem code available, then it makes it relatively easy. If you don't, then it's a hard problem. So I uh, got a copy of the Chinese remainder theorem and was able to do that, but that's in there. Um, but anyway, check that out if you're interested in, I guess, modulus math. It's probably the most modulus intensive thing I've ever done. So let's look at our next day here, which is I guess I've done day 13, so we're on day 14 here. I don't know why I said day 13. Day 14.py. Okay. So as your ferry approaches the seaport, the captain asks for your help again. The computer systems that run this port, the computer system that runs this port isn't compatible with the docking program on the ferry, so the docking parameters aren't being correctly initialized in the docking program's memory. After a brief inspection, you discover the seaport's computer system uses a strange bit mask system in its initialization program, although you don't have the correct decoder chip handy, you can emulate it in software. The initialization program, your puzzle input, can either update the bit mask or write a value to memory. Values in memory addresses are both 36-bit unsigned integers. For example, ignoring bit mask for a moment, a line like mem8 is equal to 11 would write the value 11 to memory address 8. The bit mask is always given as a string of 36 bits written with the most significant bit representing 2 to the 35th on the left, and the least significant bit 2 to the first, that is the 1 bit on the right. The current bit mask is applied to the values immediately before they're written to memory. A 0 or 1 overwrites the corresponding bit in the value, while an X leaves the value unchanged. Okay, so considering the following program, mask is X with a 1 somewhere and a 0 at position 2, and we'd say mem8 is equal to 11, and mem7 is 101, and mem8 is equal to 0. Program starts by specifying the bit mask. The mask it specifies will overwrite 2 bits in every written value. The 2's bit is overwritten with 0, and the 64-bit is overwritten with 1. The program then attempts to write 11 to memory, address 8. By expanding everything out to individual bits, the mask is applied as followed. So I guess that's a decimal 11? And our mask is what we had up above. And so everything with a 0 goes to 0, a 0, 1 is going to a 1, a 1x is going to a 1, and 1, 0 is going to a 0, and a 1x is going to a 1. Okay, so because of the mask, the value 73 is written to memory address 8 instead. Because of the mask, 73 is written to 8 instead. Then the program tries to write 101 to memory address 7. Okay, so we've got our decimal value for, or our binary value for 101, and we've got the mask, and then we're going to get a result from that. This time the mask has no effect, as the bits it overwrote were already values the mask tried to set. Finally, the program tries to write 0 to address 8. So decimal 0, everything's 0. And we're writing that to address 8. '64 is written to 8 instead. Okay, to initialize your Fairies docking program, you'll need to sum all the values left in memory after the initialization program completes the entire 36-bit address begins. Initialize to the value 0 at every address. In the above example, only 2 values in memory are not 0, 101 and 64, producing a sum of 165. Execute the initialization program. What is the sum of all the values left in the memory after it completes? Okay, and let's look at the puzzle input. Okay, we have a mask, and then we have memory locations, and I guess we're just going to sum those up. Okay. Okay, so this is binary math. Looks like some combination of binary math. I haven't done this since my hardware days, working with hardware. So let's see if we can figure this out. So let's see. We've got the mask up there, and let's take our input here. We'll just try this and see if we can sort of step through this. I'm going to use PyTest for this. And I'm going to say import PyTest. I'm going to make a fixture for this. Let me say def basic input. And so this is a PyTest fixture. And just going to say return triple quoted string with that in it. Okay, so there is my basic input. And then I'm going to want to have something that reads the mask in. So let me just read the rules of this mask again. So it's got x, 0, and 1. The bit mask is given as a string of 36 bits written with the left most significant 2 to the 35th on the right and the least significant 2 to the 1st on, or sorry, 2 to the 35th on the left and 2 to the 0th on the right. The current bits mask is applied to the values before they are written to memory. A 0 or 1 overwrites the corresponding bit in the value, while a x leaves the value unchanged. Okay, so we take our, whatever our input is, we convert it to a binary, and then we see if there's a 0 or a 1 there in the mask. And if there's a 0, we replace whatever's in our binary value with that. If there's a 1, we replace it with that. So the first one here is 11. There's the value for that. We've got a 0 down here, so we're going to update that, but everything else is a 1. Okay. Let me save this. And let's make a terminal here. Okay, so here's our terminal. And okay, so let's write some code to parse this. I'm going to call this day14.py. And Emacs is having issues with that, so I'm going to touch it here, day14.py. Okay, and I'm just going to write a generator to parse this. So what the generator is going to yield is a tuple with the mask and the memory locations there. So let's say parse input, and I'm going to have my text. And then what I want to do is I'm going to say lines is equal to text.strip. We're going to strip off any new line from this, and we're going to split it after that on new lines. And then I'm going to say for line in lines, if line dot starts with, if it starts with mask, then we're at a new section here. I'm going to say, I'll just call this a group, is equal to this. If line starts with mask, then we're at a new group. And I'm going to say mask is equal to line dot split. We're going to split this. I could use a regular expression here. I just split it on equals and take the end of it and strip that. Okay. Okay, if it doesn't start with mask, okay, and what I want to do then is I want to yield my mask. If I have a mask, I'm going to say mask is none. If mask, yield my mask, and then yield my group with my mask. Okay, I guess I don't need to initialize this group over here. Okay, otherwise I have a group here, and I'm going to say group.append. And what am I going to append? I'm going to append a memory location and a number. So maybe I'll use a regular expression to pull this out, I guess. I could split it as well. Import re, and then I'll say, we're going to say re.match. And what are we going to match? We're going to match, I'm going to do a raw string here, and then I'm going to match MEM, And then we're going to have a square bracket here, and I need to escape that with a backslash. And then we're going to have some digit inside of here, star, and then we're going to have another backslash, and then we're going to have a space, which should be a backslash s. Then we're going to have an equals, and we're going to have space. Then we're going to have another digit here. And so I think I want to take that, and then I want to do groups from that. And if I do groups from that, the group will be the location with the value, I think. Okay, when we get to the last line, we'll just, after we're done with this, we're going to yield again if we have a mask. Okay, let's just try this. I'm going to go to my test here, and we're going to test parse. Def test parse. It relies on basic input, and I am going to say assert day 14 dot parser, parse input of basic input. This is going to give me a generator. I'm going to convert this into a list. So I throw it into the constructor, and that should be equal to, I'll just say empty list here, and let's see what that looks like from the command line PyTest. Okay, day 14 isn't there. Let's import day 14. Okay, and we need to match, we got our regular expression here. We need to match our line. So there's what we're matching, and we're going to match that against line. Okay, and I'll do a dash V here. Let's get the full diff. And this is what we have here. We've got this with 8 at 11, 7 at 101, and 8 at 10. So that looks okay. Maybe what I want to do is I want to convert these numbers here. Whoops. I want to convert these numbers to, well, they're strings right now, but I want to convert them to numbers. Okay, let's just make sure this works, and I'll fix that. Okay, we got a syntax error. So I've got an assertion here. I need to close off that. And then I'm going to close off this, and then I'm going to close off that. Okay, I've got my parentheses galore here. Okay, I've got a list with that in it. This is the end of my groups. This is the tuple in there. This is the end of that. Okay. Okay, now convert this to an integer here. maybe I'll say this. I will say location and value is equal to this. The result of my match here. And then I'm going to append the loc, which is going to be a tuple, and the value, and I want both of those to be an int. Int loc, int value. Okay, append takes one argument to given. So I'm going to append this tuple here. Okay, let's try this. Okay, so I think I'm good now. I've got numbers in there. Let's convert these back to numbers. Okay, just push that back up the hill. Okay, so our parsing looks like it's working. Now what do I want to do? I want to start doing some math here. Okay, so what does our memory look like? You either update the bit mask or write the value to memory. Values in memory addresses are both 36 unsigned integers. Ignoring bit mask for a moment, a line like mem811 would write the value 11 to memory address 8. Okay, what does the memory address look like? To initialize your programs, the sum of all the values in the memory left in the memory after the initialization. The entire 36 address space begins initializing to the value 0 at every address. Okay, so there is just 0, and then we're going to shift. So I think what we're going to do is we're going to take our value, we're going to convert it to binary, then we're going to run it through the mask, and then we're going to shift it over. We're going to shift it over, and we just add up what we're shifting, or are there 36 values that we're adding together? There are only 2 values in memory, not 0. 101, that's 7, and 64, the address is 0. Oh, okay, so each of those values, each of those memory values starts at 0, so it's not 1. Okay, I think I've got it. Okay, so how are we going to do this masking? That's going to be interesting. So if I've got like 8 is the value 11, so if you want to make 8 to 11 or 11 to binary, I mean, we can say like bin 11. So that's the value of 11. But we can do math operations on 11. I can do like 11, and we can like shift it over 1, which is 22. So we should be able to do that. Like if I have, I guess we don't need to shift anything over. We just need to apply the mask. Okay, so how do we apply the mask? Let's think about that. So if it's X, a 0 or 1 overrides while an X leaves the bit changed. Okay, so we need to figure out if we've got a 0 at some location, then we're going to write a 0 at that location. And if we've got a 1 at that location, then we're going to write a 1. So that is taking our mask. So how do we write a 1? We would do an OR with our mask. Anywhere where there's a 1, we would put a 1. Anywhere where there's a 1, we put a 1, and then we OR that. So, okay. And then a 0, anywhere where there's a 0, we do put a 0 and then we AND it, and that will give us a 0 at that location. Okay. So let's look at our masks. Our masks are probably like arbitrary values, like 0s and 1s. Yeah, 0s and 1s. Okay, so I think what I can do is I can take my string there, and I can create 2 masks. I can make a 1 mask, and basically I'm going to do and X is going to keep it the same, and a 1 is going to change it, right? I need to write this down. I'm going to say def apply mask, and we're going to have a value, and then we're going to have a mask. And so if the mask is X, leaves value same, 1 or 0 changes to 1 or 0. Okay, so let's just try this out here, maybe with a simple example here, where I have like apply mask, and I have a mask with XXX 1, and I apply that to 3, changes value to 1. Now let's apply it to 4. Okay, and so that should be, 4 should be like this. I'll just comment it out down here. 4 is going to be like 0, 1, 0, 0. And so applying the mask to that XXX1, the result of that will be X is going to leave the value same, 1, 0, 0, 1 is going to change the value to 1. So that should be a 5, I believe. Okay. So let's try this out here. Apply mask. So how am I going to get this? If it's a 0, sorry, if we're applying a 1, we want to do an OR. Okay, so I think we want to replace the X's with 0. So let's run the 1s. Run 1. So what we're going to do is we're going to say one mask is equal to, and we're going to say mask dot replace, and I've got mask and value wrong up here, so I'll just switch this. Okay, so if I'm applying it to the ones here, I'm going to replace x with a 0, and then I'm going to AND the result. And so if I've already got a 0 and a 0, that will stay the same. If I've got a 1, no, if I've got a 1 or a 0, okay, so I want anywhere where I'm combining with a 1 to go to 1. That would be an OR. Everything else I want to replace with 0, 0 or 0, or 1 or 0. So I'm going to OR that. Okay, so I think the result of this should be return. I'm going to convert this to a binary mask. So I'm going to say int mask base 2. And I'm going to do an OR here, which I believe is a pipe, double pipe like that. And I'm going to OR that with my value. Okay, let me just run my doc test here and see if this works. PyTest -- doc test modules. Okay, it's a single pipe, I guess. Yeah, I haven't done bit masks in a while here. Okay, invalid literal for int with base 2. And okay, so I need to do my one mask here. One mask. Okay, that looked like it worked. Awesome. Let's do our 0 mask. So I'm going to just do something similar here. If we have a, instead of this, maybe we have, I'm going to do 3. And so we'll do x0 with 3. Say val is equal to this if x in mask sorry, that's not if x in max, that's if 1 is in mask. Okay, and then if 0 in mask, so 0 and 1 can't be in the same place. And if we're at 0 or 1, we keep those values. No, if we're at 0 or 1, we change the value to 0 or 1. So this one here is going to be, what's going to be 3 is 0, 1, 1. We're going to apply the mask of x, x0, x. And so the result of that, x is going to keep the value the same, 0, x, 0, 1. So the result of that should be 1. Okay. So instead of having a 1 mask here, I'm going to have a 0 mask, and that's going to be a mask. We're going to replace the x's. So what do we want to do with zeros in there? If we've got a 0 in there, we want it to go to 0. We're going to AND it. I think we want to replace them with 0 and just AND it. Let's see if that works. return val. And this is not a 1 mask, but a 0 mask. I expected 1, I got 0. Why did I get 0 there? 0, 0, 0, 0. So everything's 0. I want to replace it with 1. I think it's 1 and or. Expected that, I got 15. Okay, so let's see here. We're going to replace all the x's with 1s. And so we would keep that. It's not an or, it's an and. So 0 and 1. Okay, I think that's it. Okay, let's try their tests here that they have on the website here. So I'm going to do these with our test here. So we've got test parse here. Let's test parse and mask. So I'm going to say that these are my groups. And I'll just say that that's a list of this. Okay, so I've got my groups here. And then I'm just going to have one of those. So I'm going to say 0. And then my mask and my vals is going to be my groups. And this is going to be a single group. And then I'm going to do a self, I'm going to do an assert that day 14 apply mask. And I'm going to apply the mask, which is the mask, to vals 0. And that should be equal to, what does that say that that's equal to? 73? Let's see if this works. Okay, and I got an error here. Let's just drop into the debugger here, --pdb. Go up, go up, go up. We'll continue with that. Okay, so let's look at our val, 8 and 11. Okay, so that's my problem. My val here, so that's my vals. So loc amount is equal to vals 0. And this is going to be mask. And this is going to be amount. Let me fix my doc test. Okay, quit that. Let's run it again. Okay, that looks like it works. Wow, nice. Okay, let's just do a few more tests here. So I'm going to assert that we're going to apply our mask to vals 1 and 1. This will say 73. Let's just see what it is. And it shouldn't be 73, it should be 101. So that's the answer over here. 101. Yep, 101, and the last one's 64. Awesome. So this should be 64 here. Okay, so that looks like it's working, knock on wood. So now what we need to do is we've got these locations, and what are we going to do? Everything's 0, and then we're going to sum all the values left in the memory. So we've got 36 entries where it's 0. So I'm just going to make a part 1 here. Def part 1, and I'm going to say mem is equal to, I'm going to do a dictionary here. I'm going to map the key, which is the location. So I'm going to say loc 0 for loc in range 36. So there's my dictionary. I'm going to get my groups here. I'm going to say groups is equal to parse input, and that's going to be open input.txt. We'll put an encoding here just for funsies. If you're on Windows, that might be problematic. UTF-8, and we'll just say .read. Okay, and then we're going to go for group in groups. We're going to loop over our groups, and our mask comma vals is going to be group, and then we're going to do for loc comma amount in vals. We're going to use some unpacking there, and then we're going to say that mem loc, what do? We add the value to that. We're going to sum all the values. So we're writing this value here, overwriting the value that was there. So it's just equal to, we're not doing a bit mask there. Okay, so it's just equal to apply mask, and we're going to take our mask and we're going to take our amount. Okay, and then what we're going to return down here is the sum of all the memory at that location. Okay, I'm just double checking what it says here. In the above example, the only two values are not 0. 101, address 7, and 64. What about 73? How is 73 not 0? Oh, because I'm overriding it? Oh, I'm overriding it. mem8 is equal to 0. Okay, so we're just overriding it. So we should be able to say here, return, we got mem, and we just want the sum of mem.values. Okay, let me save this here. Okay, I'm going to copy, or I don't know if I can move it with my silly permissions here. I need to figure out why the permissions got changed on WSL2. Oh, it looks like I could. Okay, so I'm going to say Python day 14, and it's not going to do anything here because I need to invoke it. So I'm just going to come down to the bottom here and say part. Actually, I'm not going to do that. I'm going to put it if dunder name equals the string dunder main. Then we're going to do part 1. And we need to print that. Okay, that is the result I got. Let's take that and plop this in here. Yay, that's the right answer. Okay, so this concludes part 1 of day 14. We had a fun time doing some bitwise manipulation here. I had to refresh myself on whether it's double pipe or single pipe. So what did we learn here? We leveraged a fixture there, which I didn't really need to make it a fixture. I only used it once. But it was nice to have that input there along with their output. I could make a test that allowed me to validate that. I did some parsing up here with both stripping and with a regular expression. And then I used a generator just to yield groups of those. And then I've got this apply mask function. I used a doc test to test that and make sure that that worked. And then finally we tied it all up with this part 1. Okay, hopefully this was useful. We'll see you later. I'm not seeing any comments in the chat. Bye.